Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, today's topic for the lecture is mass percentage of different components in solutions. So, my dear students, before starting this topic, I would like to revise the topic called solutions that we have learned in the previous videos. So, I'm revising that. So, first of all, I'm mentioning what is exactly solutions. Solutions. What are solutions? It is the homogeneous mixture. First of all, it is homogeneous mixture of two or more components. So let us first of all understand what do we understand by the word homogeneous. What does this homogeneous word stands for? It stands for uniform composition or concentration throughout, that there will be the uniformity in the composition or concentration throughout the solution. That stands for homogeneous solution, that the one component is totally mixed in the another component and there is not any visible boundary of separation. Visible boundary of separation. Another point about solution is that the combining components, the mixing components does not reacts chemically with each other. There is not any chemical combinations or chemical bonds between the different components of the solution. That is, mixing component does not react chemically. Now, the component which is in excess, which is in excess is called solvent. And obviously the other component will not be in excess, or it will be always less than the solvent, then that is called solute. Or we can write the component which is less in comparison to solvent. In comparison to solvent is called solute. Word is solute. Now, what's my next topic? When there are two components, when there are only two components, that is solvent and solute, then that solution is called binary solutions. That is, we are having two components, the one is solvent and the another is solute. So that's why we call it a binary solution. Now I am taking solvent plus two solutes. When we are having one solvent, obviously solvent remains only one, but solutes can be of two different types. So total we are having three components, that is one solvent and the two solutes. Total, when three components are there, we call it ternary solution. My dears, when we are having three components, three solutes, solvent plus three solutes dissolved in one solvent. Now we are having total four component. The one is a solvent and the three are the solutes. Then we call it quaternary solution because we are having total of four components. That's called quaternary solutions. So let's now move to our topic, that's mass percentage. So here first of all I am marking solvent plus solute will form me solution. In this I am assuming my solvent to be the capital A, my solute to be the capital B. So the solution formed will be AB. My solution is AB. So what's my topic? That's the mass percentage. In mass percentage, I have to find the percentage of mass of A in the total mass of solution or the percentage of mass of B in total mass of the solution. So let us talk about mass percentage of only A. So first of all I am solving the mass percentage of A. So mass percentage of A will be equal to the mass of A divided by total mass of solution into 100. Now the mass of A, what is total mass of solution? The total mass of solution will be obviously the mass of A plus mass of B into 100. I will get the mass percentage of A. Now for calculating the mass percentage of B, we can simply subtract the mass percentage of A from 100. So let's talk about mass percentage of B. Now mass percentage of B, that will be equal to the 100 minus mass percentage of A, or you can also calculate it like the mass of B divided by total mass of solution into 100, or it can be like mass of B divided by mass of A plus mass of B into 100. So that comes out to be mass percentage of B. I would like to mention one more thing, is that mass of A divided by total mass, that is mass of A plus mass of B. If I am not multiplying this thing into 100, then this is called mass fraction of A. Then it is called mass fraction of A. Fraction is always evaluated with the total value of 1. Out of 1, how much fraction wise A is present? So mass fraction of B, mass fraction of B will be equal to the 1 minus mass fraction of A. I'm repeating it again, that in case of percentage, the maximum percentage is obviously 100, and in case of fraction, the maximum fraction is only 1. So that's why I have to subtract the mass fraction of A from 1. I will get the mass fraction of B, or mass fraction of B is also written as mass of B divided by total mass, that is mass of A plus B. That's also called a mass fraction of B. Hopefully, my dear students, you got the topic, that's mass percentage of different components in the solution. Firstly, I have introduced you what is solutions. After that, I have given the formula how to evaluate the mass percentage of A or mass percentage of B in this solution. So now I'm going to solve some numericals for you. Now the first numerical, what is it saying? It is saying that a solution is prepared by mixing 5 grams of substance X in 50 grams of water. Calculate the mass percentage of substance X. First of all, water is always solvent, so that means my substance X is solute. So I am writing substance X, it's my solute, and its weight is given to be 5 grams. Now water is solvent. My dear students, I would like to mention over here that water is universal solvent. It remains solvent. Water will never act as solute in any case, because water has the highest dielectric constant, because water has highest dielectric constant. And what's that value? It's 79. Water will be always universal solvent. Water will not act as solute in any of the case, whether the water is in excess or water is in the less quantity, but water will remain as solvent. Now, what's its weight given? It's given is 50 grams. Now, let us calculate first of all total mass of solution. Now, total mass of solution, that will be equal to the mass of substance X plus mass of water. Mass of substance X is 5 grams, the mass of water is 50 grams, and the mass of solution comes out to be 55 grams. So let's calculate mass percentage of X. It comes out to be mass of X divided by total mass of solution into 100. Now, what was the mass of X? 5. What was the total mass of solution? It was 55 grams into 100, and this percentage comes out to be 9.09%. So that was my first numerical. Please have a look. Now, my dear students, I am moving to the next numerical. Now, next numerical. An aqueous solution of glucose is 10% by mass. Find the weight of glucose in 500 gram of solution. So what is given? Here the question is saying that we are having 10% glucose solution, 10% glucose solution by mass. Now, let me write down the formula first of all. The mass percent of glucose will be equal to the mass of glucose divided by mass of solution into 100. So let us now put the values the given in the question in the formula. First of all, what's the mass percentage of glucose? It is 10%. So it's a 10%. I have to evaluate the mass of glucose. The mass of glucose divided by, what's the mass of solution given over here? It's 500 into 100. The mass of glucose, it comes out to be 50 grams. Hopefully, my dear students, it was a very easy and a simple question. So please have a look. So now I am moving to the third numerical. Now this is a very unique case. It's a unique numerical. So it's a third question is saying calculate the percentage composition in terms of mass of solution obtained by mixing 400 gram of 30% solution and 500 gram of 40% solution. In this question, two solutions are given. I am marking it like, let it be like solution number 1, and here I am writing solution number 2. The numerical is I have to add solution number 1 and the solution number 2, and then I have to find out the final percentage of solute in the solution. So what's the solution number 1? It's 30%. It's 400 gram of 30% solution. 400 gram of 30% solution. And what's the solution number 2? It's 500 grams of 40% solution. So let me write the formula of the mass percentage. The percent mass of solute will be equal to, obviously, the mass of solute divided by the mass of solution into 100. So what's the percentage of solute given in solution number 1? It's 30%. I'm writing 30 over here. Mass of solute I have to evaluate. Now what's the mass of solution? It's 400 gram. Total 400 gram of solution is given in the question. So it comes out to be 400 into 100. The mass of solute comes out to be 120 grams. That means 120 grams of solute is present in 400 gram of solution. We can solve it in one more way. That will be the more practical and the easy way. Let us solve it. Let us solve it. Now, here the question is saying that we are having 30% solution. 30%. So now let's talk about it. What does 30% stands for? 30% stands for 30 gram of solute. 30 gram of solute in 100 gram solution. The percentage can be written like 30% stands for 30 gram of solute in 100 gram solution. So that means 100 gram solution possess 30 gram of solute. Then how much weight of solution is given in the question? That's 400 gram. Then 400 gram of solution will have 30 divided by 100 into 400. It comes out to be 120 grams. So I have solved the first part in two different ways. This was the first one or this was the second one. You can follow anyone, but you should do the numerical in the right way. It should have the right answers. So you can opt for the option number 1, or you can go for the option number 2, the way you like, the way you feel easy to solve. I feel easy to solve by the method number 2. So I'm going to solve the solution number 2. I'm going to solve this solution number 2 by the second method. So let's solve it. Now the second one is 40% solution. 40% stands for 40 grams of solute in 100 gram solution. That means 100 gram solution possess 40 grams of solute. Then what's the total mass of solution? 2 is given, that's the 500 grams. Then 500 gram of solution will have 40 divided by 100 into 500. And it comes out to be 200 grams of solute. So I got both the values, that is the mass of solutes in both the solution, in solution number 1 and the solution number 2. Now I have to add these two solutions. I have to add these two solutions. If I'm going to add this solution, then first of all I'm going to calculate total mass of solutions. What's the total mass of solution? Obviously mass of solution 1 plus mass of solution 2. So now what's the mass of solution 1? It's 400. It's 400 grams. What's the total mass of solution 2? It's 500. It's 500 grams. My total mass comes out to be 900 grams of final solution. My final solution comes out to be 900 grams. So now let's talk about their masses of solutes. Now let's talk about total mass of solutes in both solutions. In solution number 1, we have calculated the mass of solute to be 120 grams. It's 120 grams in solution number 1. The solute is 120 grams in solution number 1, and the solute is 200 grams in solution number 2. So it's 200 grams in solution number 2. My total solute comes out to be 320 grams. So now let's calculate. Mass percentage of solute in final solution. So that will be equal to the total mass of solute in final solution divided by total mass of final solution into 100. What's the total mass of solute? Total mass of solute is 320 grams divided by what's the total mass of final solution? It's 900 grams into 100. My answer comes out to be 35.55%. So that comes out to be mass percentage of solute in final solution. How will you evaluate the mass percentage of solvent? I will simply just subtract 35.55 from 100. I will get the mass percentage of solvent. So that's my mass percentage of solute. I hope you all understood today's lecture. I have given my phone number on thumbnail of this lecture. So if any one of you wants to book a paid one-to-one online class to clear doubts, contact me on my number. Please like, subscribe and share my channel to maximum number of students. Don't forget to subscribe. Stay blessed.